Can you see me behind this? Yes, I'm not the tallest guy in the room. Good afternoon. Really interesting topics we had the opportunity to see today, and I will go really quick on what I want to share with you. So my name is Rene Contreras. I'm originally from Chile. Been working on aquaculture for the last 20-something years for different companies and different places around the world with different species. And for the last 4 years here in this beautiful spot in Tasmania. Let me see if this works. Yes. Okay, so a lot of years ago, I don't want to say how many, a long time ago, when I was a little kid, not too far away, my mom asked me, Rene, if you have the opportunity to go to the space or to the deep sea, where do you want to go? And I said the space because I want to wear these fancy suits of the astronauts. And she said, oh, I would prefer to go to the sea. And I asked her why. And she said, because we haven't discovered everything that is at the oceans. And that caught my attention, that statement from her. And I started to investigate. And I found a statement from Jacques Cousteau, a French scientist. And he said, in the future, we need to farm the seas or the ocean. We need to farm in the ocean. And that caught my attention. And this was 50 years ago. And on that point, I said, okay, I want to be a fish farmer. I want to work in aquaculture. And there is a lot of things around aquaculture that I would like to share with you, but we don't have enough time to go through all of it. But I want to go with you on a few of these topics. The first of all is that an average adult consumes over 700 kilos of food per year. Okay, that's a lot of food. Over 700 kilos of food per year. And 9% of that food came from proteins of meat, land or fish meat. And as you can see in the graph below there, the one in the bottom is beef, which is quite stable. So the graph goes from the 60s until the last 2 years ago. So beef is quite stable. And this second one here is poultry that have a big increase. And this one here is seafood protein source. You can see that there has been a really big increase, and actually the meat consumption is the double from the 60s to these days. So it's quite high. Now, as you are aware, because it seems that we have a lot of scientists in the room, 70% of our world is ocean, okay, and 30% is land. But the funny thing is to be able to collect all these sources of protein, we just get only 7% of the protein consumption is coming from fish meat. And all the rest is coming from land animal or other kind of source of protein. So just 7% for a world that is 70% covered by ocean. And the most concerning part is about this one. The United Nations say that for 2050, we will be 9.7 billion people in the world. 9.7 billion people in the world. That's a lot of people. And we have the responsibility as aquacultures to feed all the population in the world. So then the question is, okay, how can we feed them? So if we go from our current food consumption up to this 9.7 billion of people, we are talking about a 28% of increase in protein production if we keep eating in the same way that we currently eat. So it's 28% increase. This is 133 million tons of extra protein production. So the United Nations says, okay, from these 133 million tons, 43 will be from fish meat or seafood. But actually, during the last years, they say, okay, no, we need to increase that amount because we don't have the options to increase the protein source in land because we run out of land. So we need to increase the quantity of protein that is coming from sea, okay? So the first thing is, okay, we need to produce more feed. How we can do it? So aquaculture is a must. You can see sometimes in the magazines, in the newspaper, people saying aquaculture is a good thing, it's a bad thing. We don't have that option. It's a must. So the question now is, how can we do it better? How can we improve that? How we are able to produce protein in a good, sustainable way? So let's have a look. Probably it's not easy to see, at least from this point here, but this is how it looks, the Atlantic salmon production, which is the business where we are, trout and Atlantic salmon. This is just for Atlantic salmon. You can see that here we harvest 74,000 tons of Atlantic salmon, and our consumption in Oceania is 64. So we are quite balanced, okay, between how much we can produce and how much we consume. So or in our case, 100% of our production is for internal consumption here in the country. But look at these places like Norway. Norway produces 1.4 million of tons per year, and they are able to export to the different market. Look in South America, so they produce 700,000 tons, and they have a tiny consumption. So this is how is the distribution, but we are a tiny industry compared with these big giants as Norway and Chile. We are a tiny one. But even that we are a little player in this big industry, we have something really important. So, and it's what I want to share with you. So as I said, we need to say, okay, we need to produce more food. We need to do it in a good way, and we need to do it better. And aquaculture is a really good way to do it because we have 70% of our ocean available in order to do it. Now, there is some challenges, and we have been talking today a little bit about temperature and how our waters and how our land change depending on the temperature that we have over the years. So definitely the temperature in at the sea and the rivers is increasing. Okay, so that's again is a fact. So probably it's not easy to see here, but the farming temperature in Scotland, in Norway, in Chile for salmon go up to 14 degrees over summer. Okay, 14 degrees. So when the temperature reached 16 degrees, that 10 years ago wasn't that often, but now it's really often, the fish are really stressed and they start to die or get disease or don't grow. So it's a really big challenge. So we say, okay, how can we farm fish if the temperature is increasing every year? So in the past we have a few or a couple of events during summer, and now we have a lot of events over summer overseas in Norway or Chile. So ideally we want to have 14 degrees, but the temperature reach 16, 17 degrees easy. So it's a really big challenge at the moment. And in the past, all the breeding programs was focused mainly in growth production. At the moment, they are moving to warm temperature tolerance and to prevent disease. It's one of the main focus at the moment on the breeding programs. So then I came here to Australia 4 years ago, and part of my task as GM is to create a breeding program, a genetic program. And one of the things that caught my attention is this big river here. The river here, we have a sea farm in Rowella, and the river here reaching summer up to 22 degrees. 22 degrees. And they said it's impossible to produce fish on 22 degrees. That no way. I came from Canada, from Norway, from Chile, where we have 16 degrees and the fish are really stressed. So it's impossible to do it. Then I get there and I saw fish eating and swimming with no problems at all with that temperature. And I say, okay, wait a minute, there is something here. and we start to investigate, okay? And we say, okay, we have amazing opportunity in here, because if these fish are able to perform with this temperature and conditions, they will be able to perform really well in the near future. So what we did is, okay, let's do a breeding program, okay? So the first statement is, when someone tell you, okay, these fish, they are GMO and all that, that's not true. Okay, there is no production of salmon with GMO here or even overseas. There is only one company in Canada. They are doing some research on GMO, but there is no GMO fish. We don't touch any gene or edit any gene on them. What we do is this, and this is going to be just for you, okay? I will give you a secret and hopefully stay in these four walls. Okay, so we have a selective breeding program, okay? So the selective breeding program is based on families, okay? So each year we produce 200 families, okay? What is a family? It's a female fish and a male fish. So what we do is we collect the eggs from the female, we collect the milk from the male, and we fertilize these eggs, okay? And this eggs is one family. So we produce 200 families from female, male, 200 family of those ones. And we keep on individual incubation, each of these family, to don't mix between them, okay? And then one of these, and then when the fish are ready to be moved, we separate them on in two different groups, each of these family. So one group stay here in Cressy, in our freshwater facility, all their lives. Okay? So from these 200 family, we split them into one group stay in freshwater all their lives during 3 years, and they become broodstock at the 3rd year. Okay? And then we have another group from the same family that we send to our sea farms in Macquarie Harbour here in Rowella. So we put there on a specific pen that we call the evaluation pen. So on this pen, we have fish swimming from 150 families. So we have 200 families. So we have representation from these 200 families swimming on this pen, okay? So at the 2nd year of age, which is the harvest time, we harvest this pen. We harvest this pen and we take all of these fish to our factory in Devonport. So when the fish goes to Devonport, we have all these fish in there, and what we do is an assessment on this fish. So with this assessment, we measure different things, like color, size, fat, survival, etc., and other things, texture, things like that. So we measure all of the things in this fish. Okay, so how beautiful these fish are, how big the fish is. And with that information, and plus that information, we also collect a DNA sample, which is a tissue sample. So we do the assessment and we take a DNA sample. Now, with this DNA sample, we are able to recognize to which family this fish came from. So what we do is we create a ranking. So we say, okay, these guys are the best growers, the biggest fish. These fish are the best color, and these have the best fat content. These fish have the best survival. So we create a ranking. And with the DNA sample that we take, we are able to trace, for a process called genotyping, we are able to trace to which family these fish came from. So basically what we say is, okay, this is the best size. So which family they came from? Family 40, let's say, from these 200 families. And this is the fish with the best color. Okay, to which family they came from? To family 80. Okay, so we have family 40 and family 80 with the best color and size. Okay, so what we do is 1 year later. Remember that the broodstock are ready for spawn in 3 years. Okay, so it takes 3 years to be ready. So the harvest happened at the 2nd year, and then we go to the fresh water 1 year later. And what we do is between all the broodstock, we do a DNA sample on the broodstock, and we find a female coming from family 40. That is the family that have the best growth, biggest fish. And then we find a male coming from the family 80 that have the best color. And what we do with them is we breed from them, and we create a new family called family number, 100. And this family 100 have the best genetic potential from growth and from color, for example. So we can do that, and then we create this new family. And this new family, we split them in two, again, over. And then we create another family, and we can do it over and over and over and over. And we are able to improve our genetics on that way. But also, we are able to avoid the families that we don't like. So if during this assessment, we realize that the fish didn't perform well, or the mortality was high, or the color wasn't good because they spent their life in sea farms with high temperature, we can remove them from the breeding program and just keep the one that performs good or have a good performance. So on that way, we are able to perform over and over and over our genetics. And therefore, we can get better and better and better fish just with the selective breeding. Now, the big question here is what's happened if we take one of these fish and we put them in Norway? Or what's happened if we take one of these fish and we put them in Chile, where the fish with 16 degrees are dying, and these guys with over 20 degrees are performing with no problem? So here, we have the future of the aquaculture. We have a lot of people coming from Europe, from North America, to look at these stocks, because these fish have a really good potential in the near future to be a really good performance and be able to feed the world with this technology. Thank you.
Thank you very much. Stay right there.